Good afternoon, good evening, good morning, depending on where you are in the world. My name is Don Bowman. My company is Agillicus. And today we're going to talk about a more exciting topic than maybe some of the others. We're going to talk about generation AI and how cyber criminals are adopting it and what that means for critical infrastructure. And today I thought I'd start with the nothing but the facts, ma'am, to quote Dragnet, but the cold hard facts. And these come from CISA. What they did is they looked at all of the successful attacks on the critical infrastructure they had a remit over, and they put them into the categories according to the MITRE attack framework. And this shows where did the attack come in, how did it go sideways, etc. So basically its path. And the really not perhaps unusual, but maybe intriguing thing is 42% of the attacks used a valid account. And these are actual attacks. This is not 42% tried to use, 42% succeeded in using an actual valid account. And what does a valid account mean? Well, it could be a person. It could be you with your username and password that you also use on Facebook. It could be a system account. There's this machine and it's sort of used by people infrequently and they administer it, but they're not logging in as people. It could be a device. Hey, I've got a router and it's got a fixed account in it. It could be what are called service accounts, which are machine-to-machine communication. But in this particular case, they were able to gain control of 42% of the valid accounts, or that's how they got in, was through valid accounts. 26% use spear phishing, which is actually account adjacent. And so in spear phishing, I send you usually an email, but I guess it could be SMS or leave a post-it note on your desk or something. And in it, I encourage you to do something. I'm like, hey, I'm your IT admin department, and we've got this new pay stub system. You're going to love it. Just, log in the first time. And the way that this normally takes control of your system is it causes you to put your credentials into something that's not trustworthy, and then it relays those credentials onwards to something else. That's why I say it's adjacent to a valid account. And 10% use brute force. They guessed. So these are passwords. So you get a password that it's SCADA01, SCADA 2025. Who's going to guess that, right? Well, you're a water treatment plant and it's 2025. It might be my first guess. So 10% just were managed to successfully guess a password. This can also happen when they're in what's called a corpus, but a dump of passwords somewhere else. So, your VPN, you've created accounts for your team, and some of the people use the same account they did in some other tool that online, and that tool was breached and it's available, but they brute forced it. And when you add this up, that means that 80% of successful attacks in critical infrastructure used user authentication and identity weaknesses. 80%. So if you're spending more than 20% of your time on other things, you might be doing the wrong thing. So you're looking at hardening your door locks or looking at improving your firewall. Those are all good things to do. But if you aren't addressing the key ingress method, the key way that the miscreants are coming in the door, this is how they're doing it. This is what they're succeeding at. And it's important to realize what they're succeeding at. One of my most intriguing stories is in World War II, bombers. You're flying a bomber, you're likely only going to live a couple of missions. Like the mortality rate was tremendously high. It's a slow-moving plane, it's big, there's a lot of other planes that are trying to attack it, there's ground, anti-aircraft that's trying to attack it. And they used to paint these little targets on the side of them where they were not weak, or weak rather, and hope that the people would aim at those. And somebody had this huge insight one day. They said, because they were always reinforcing the areas of the planes they thought were weak, they said, well, why don't we look at the planes that came home and look where they have holes in it and maybe reinforce areas that aren't where the holes are. And that's really what you want to do, is you want to reinforce where the attackers are actually getting in as opposed to guessing. And in this case, it's user authentication and identity. So AI. AI obviously been on the scene for a while. I mean, we've all seen Terminator and so on. It came on the scene in a big way when a bunch of people integrated it with chat and let it loose on the world. And all of a sudden, it became accessible to the average consumer, and people started to have fun with it. They were the good uses and bad use cases for it, and it just sort of magnified humanity. People were creating deepfake nudes of people, and where people are using it to create poems and crazy pictures and whatever. But it's the boogeyman today. Everybody's like, but what about AI? And really what it is, it's a magnifier. It multiplies. So you think about the attacker that is trying to get at your goods. What are they? They're inherently lazy. If they weren't lazy, they'd have a real job. But they're like, I can do this and get by. Maybe I'll thrive. But I'll just steal from other people. And AI is their faithful servant. So the lazy people become effective because they can get somebody to do their work for them. So that's step one. So instead of them having to go do their own research and figure things out, they can get an AI to do it. And the other thing is attackers are dumb. Now, I know some are going to disagree with this statement, but the reality is there's a lot of stuff to know, and it's hard to know all of it, and you can't know all of it. So yeah, in the movies, you see that brilliant hacker who's like, oh yeah, look at this. Let me get AES 256, 496-bit RSA. I'll just hack that in with the keyboard. Your fingers would have to be awfully fast to guess that password space. But the real world hacker just doesn't know all the stuff that they need to know. And AI is their crutch. It renders the dumb people smart enough. And that means that the bar just went way down. It used to be that you had a little bit of security through obscurity, not real security, but it actually would have some benefit. In critical infrastructure, you got a bunch of PLCs hanging around, and most of the attackers out there were going after Microsoft Exchange and things like that, where there was a large number of shots on goal. They didn't really have access to a PLC to decode it and figure out its weaknesses, or your HMI or your this or that or your other thing. They didn't have access. So as a consequence, you kind of got away scot-free. The second reason you got away scot-free is you didn't have any money. You weren't a bank. But what's happened is the really good targets have started to harden up, and some of the information on the more esoteric things become more widely known, and it got into the AI and the training and the LLM and so on, and kaboom. But the other thing is the AI can do the work for you that you are too lazy or unwilling or unable to do yourself. And you got to realize that it's not just a chat and search interface. These people are using a different interface here than the average consumer that's just rolling up to gemini.google.com and saying, draw a picture of a cat, which is something I do. What we're talking is here is they're using AI to reduce the cost of the attack, both in time and effort and money, and to increase the success rate. So the first thing they do is what's called pattern space reduction. So the amount of passwords I need to try to guess if I'm going in the brute force attack on your site, I'm going to start with a bunch of patterns that relate to you. It's got your site name and SCADA and the year and some other stuff in it, and I'm going to generate a smaller number of shots on goal to succeed. And the second is it simplifies the integration. Look, you've got a bunch of weird stuff inside. We both know it. You've got this software package that you're the only person in the world that runs it, and it's integrated in a way that only this one integrator could love, and it goes through this custom integrator middleware box that nobody really understands what's in it. Yeah, we all know. But here, what the attackers are doing is they're not modeling out every single interface on everything. They're using technologies like MCP, which is a model control protocol, and that allows an AI to talk to a physical or a virtual system out there without the AI necessarily having to know. It's sort of like an adapter, if you will. So imagine you're SCADA historian, and it's run Microsoft SQL Server under it, and I run an MCP to Microsoft SQL, and then I start using the AI to query the database because inevitably there was something of interest in there. The same for your log server, etc. And the third is so the first was pattern space reduction, but the third is search space. And here, I see you run system A and B, but not C. So that reduces the amount of things I need to try. And the other one that's related to that is lateral options. I see you run A and B, which means that C is likely nearby. You can see the patterns from what other people have done. Well, you're using a Rockwell PLC. I bet you there's Rockwell panel view nearby. I bet you there's Studio 5000 kicking about. I see you run iFix. I bet you there's a Microsoft database nearby. And the collection of these that reduces the amount of time that I need to try to successfully attack you, which means I can attack more people per hour, which means I can get more money, and cause more damage per unit of my time. And it's really that leverage. It's my return on investment as an attacker. I put in X dollars and I achieve Y output. In a nation state, the Y output might be damage, economic or non-economic damage, like reputational damage. As a cyber criminal, it might be economics, it might be ransomware, it could be what have you. But the more I can do per second with the resources I have, the more likely I am to be happy with the outcome, and the sadder you are going to be. So this is where you need tools like defense in depth. You need to slow the attacker down. You need to be able to see what they're doing and react. The other thing that the attackers are using, there's this big world of AI agents out there. You'll hear, now that I've mentioned, you'll see online the agentic world. And again, for a lot of consumers, AI is a chat interface, but the agents are really where it started to kick into high gear. And you've probably seen some demos where, like, book some tickets for me. I want to go to the Canary Islands. And what that is that you are talking to the chat interface, which is talking via MCP to an agent. The agent is the one that knows how to interface to the travel sites and do the booking, etc. So we're transitioning from I ask, it answers to I ask, it does. And this is where it's going to get really dangerous. Going back to your Terminator, AI was kind of harmless when all it was doing was hallucinating and making up weird answers to, is there an R in strawberry? Look that up if you want to go down a rabbit hole. They all got it wrong. It would tell you, strawberries are delicious. They're things that grow on the ground and they're spelled this way. And no, there's no letter R in strawberry. I'm like, it's crazy bad. But now we're transitioning into they're doing stuff. They're driving cars. Somebody is going to drive a self-driving car into a crowd of people and kill people very soon. It's a terrorist attack, and they're going to use an AI as their way of facilitating it. It's gone from science fiction to certainty. It's going to happen shortly. These AI agents that can integrate to very specific things, there's no reason there aren't going to be ones either that you install in your plant or that the attacker installs in your plant. You might install them because of big data and better mean time to repair and predictive maintenance and so on. So your new SCADA historian has an agent attached to it, and that agent allows querying stuff in more of a normal query. So instead of me having to type some SQL, select star where overflow equals true, and you could instead say, hey, tell me which tanks overflowed yesterday. But the AI agents allow this scale, so it's human to AI, AI to agent. That machine-to-machine path is thousands of times faster than the human in. And that's really the thing that's been blocking them to date, is there's been a human in the loop. Once you take the human out of the loop, it really just comes down to how many dollars you want to spend on OpenRouter to talk to Grok, to talk to this stuff. So yesterday we talked a lot about botnets and command and control channels, C2s they're called. And the real objective of malware was for me to get some binary on your site, and then it would go sideways, called lateral traversal, until it found something interesting, and it would connect back home, and then it would receive instructions and do those instructions. That was the state of the art. Today's state of the art is going to be the agentic world, where the attacker is going to find an unsecured agent on your site, or they're going to install one. So the malware will be just putting an agent there, and then it's going to get AI instructions. Really interesting study was just done just the other day. You might remember the Equifax hack of a few years ago, where basically everybody in the US had their financial information leaked. It was crazy bad. And somebody put an AI together, and without telling it, unprompted, they gave it a simulation of the Equifax data systems, and unprompted and unaided, it was able to figure out that it wanted to do this attack and do the attack and get the data exfiltrated. So a bunch of years ago we saw IBM Deep Blue and Jeopardy and then Chess, and now the resources that were in those systems are available to more or less anybody for not a lot of cash online. In that agentic world, once I've got one agent on your site, I can funnel the intelligence of this AI agentic world into your site and maximize the damage. And maximize the damage might not be ransomware anymore. It might be something worse. Many of you on the call will be running cyber physical systems, and it could be damaging human life. It could be damaging your plant. It could be damaging the reputation. You imagine you're a big city and in a well-known country, and your water treatment plant goes down 3 days and 5. There's no buffer in those things. It goes into bypass mode. What is bypass mode? It means you can't swim. You can't go to the beach. And that would be very embarrassing. We saw Clorox a couple years ago. They lost a quarter's worth of production. It was hundreds of millions of dollars of damage that was done there. And some people, it might be industrial espionage. Maybe I am the competitor to Clorox. I also make some sort of chlorinated white product, and I want to knock them off the board so I'll have a better quarter. Maybe I'm in a less scrupulous country and I'm not likely to get caught. But the economic damage is not necessarily just locking your systems and asking for a couple of Bitcoin. It could be killing somebody. It could be destroying your reputation. It could be hurting people, turning off the power in a hospital and having a bunch of ICUs go dead. It could be any of those things. It's a scary world, and the AI is taking people with low morals, low work ethic, and low IQ, and it's just putting steroids into their system. So is the world all bad? Some might say yes. Some might say, look, we got some fairly simple needs here. A lot of you will be thinking, well, glad this doesn't apply to me because I got an air gap. Let me tell you, you don't have an air gap. You have something that somebody told you is an air gap, and it's got a bunch of Swiss cheese holes through it right now. There's a cellular antenna that goes over that. There's a Wi-Fi access point somewhere in there that I can reach from the side. There's somebody walking into it right now with a laptop that's been on a different network. There's a USB key being plugged in right now. There's a license manager or backup system or something that has cloud, and there's some big data, and you're not running edge compute. You don't have one. If Iran didn't have one with Stuxnet, heavily motivated people with guns who could shoot anybody that came near the air gap, they were hacked with Stuxnet. My friend, you do not have an air gap. You got some fairly simple needs. Look, you got a bunch of people. Some of those people work for you. Some work with you. Some are your partners. Some are the vendors, whatever they are. And they each need simple access to a small subset of things. And today, what all of you do is the wrong thing. You give them shared credentials. We'll create the XYZ company account, and you all share it. That's the valid credentials from the first slide that I just showed you, where a CISA said, look, this is how 42% of the attacks got in, was valid credentials that were well known that didn't get rotated. And we're going to fix that. So there's this battleground out there, and I call it the identity battleground. People work for companies. I work for my company, you work for your company. And companies attest the identity of their staff by something called authentication. We run Google Workspace. I sign in as don@agillicus.com. You might run Microsoft, and you might sign in as you at yourcompany.ca. Doesn't matter. And it's very common for us to put our blinders on and not recognize that we work with companies other than our own. And they have valid identity systems, but we don't trust them, and we don't know how to trust them. So instead, we create shadow accounts. Contractor one at MyCo, or worse, shared ones, the contractors. And what ends up happening is that single sign-on idea becomes a shared ID. And local accounts, password on system, are never changed and widely known. Back to that CISA slide, 42%, that's what happened. Convenience actually goes down. I guess now people have to remember these passwords. One of the stats I love is the average person online has 110 passwords. There's only 88 words in Wonderwall by Oasis. What's the story, Morning Glory? That song that is now locked in your head for the rest of the day. You're welcome. How can you remember them all? You don't. They're shared. You have used the same password on at least 2 systems. I know you have. Some of you will run password managers and lie to me and tell me that you haven't, but you have. And that's what's happening here is those passwords are getting shared, they're not getting rotated, they're actually less convenient, and this leads rise to places like the Oldsmar water treatment where the TeamViewer got put in a bad place and got used to do bad things, and bad stuff happened. So there's this concept of a shared custody and shared destiny. I'll bring this back to AI in a second, but really since 80% of the attacks used identity and credentials, I don't see any reason it's going to be different with AI. I think it's just going to go faster. So they're not going to use AI to make the 20% of the pie bigger. They're going to use AI to make the 80% of the pie easier. That's what's going to happen. Because it's already demonstrated as the easy way in. The only reason they're not doing more per second is the amount of keyboards and hands they have. So there's this concept of a shared custody and shared destiny. So if you look at my little Venn diagram on the right, where the customer works with 2 different partners, and if you can share the authentication, you should be able to trust that the partner company you work with and have a contract with, in turn, has some level of trust into their own staff. If somebody leaves their team, they're going to take them out of their identity system. If you could allow all of them single sign-on, with their own natural credentials. It means you won't have any shared credentials. You won't have any passwords kicking around. You won't have that 80% problem. Spear phishing, much harder to do actor in the middle interception when there's no password to intercept and you're using multi-factor with passkeys, which locks it to your device. Much harder to do, hey, I was able to find this password in a corpus and do the brute force attack. Much, much harder because it doesn't, there's heuristics you can do there, GeoIP blocking, etc. And this comes down to an industry best practice called zero trust. Zero trust is basically three things that you need all three of to get. So the first is the who problem. Who are you? Identity. If I know who you are as an individual, or in the case of the service account as a system, and there's nothing shared about it, checkbox 1. The second is the what problem. What are you allowed to do? If I have the what problem down to a specific thing, so what is not, you're allowed access to my plant. That's not a what problem. That's basically just YOLO. The what problem is I'm allowed read-only access to HMI 2. I'm allowed to upgrade the firmware on the robot arm only when the safety pin is in and I know that there's nobody around. That's what. You need what on a fine-grained basis. And then the how problem is, how do I get you there? If I'm getting you there by just VPNing to the whole network and saying, hey, stay out of the bad areas, I didn't achieve anything. But if I get you there in such a way that you can't get to anything else you're not allowed, if I have who, what, and how solved per person, per resource, fine-grained, I have zero trust. It's not as hard as you think. With Agilicus, you can roll that out in a couple of hours and be ahead of the game. And this brings into one of my favorite jokes, and I'm going to tell it again. I've told it a couple of times before. There's two hikers. They're out hiking, as one does, and they run into a bear. And the first hiker bends over and starts to tighten his shoelaces. And the second hiker is like, what are you doing? You can't outrun a bear. He says, no, I just need to outrun you. Here's what you need to do with zero trust, and here's what you can do with Agilicus. You don't need to be better than all the attackers in the world. You just need to be better than your neighbors. Because if your neighbors are weaker, they're the ones going to get eaten by the bear, aka the attacker. And you will get away scot-free, or you'll have time to react, you'll see what they did wrong, and you'll be able to correct. So you just need to be better than average. You don't need to be perfect. So I'm coming back to this, you're going to say to me, look, we have an air gap. This doesn't apply to us. I read that CISA report. Yeah, that's critical infrastructure, and I'm critical infrastructure, but I don't know, those people have something different than me. They don't. So the reason they don't is there's a set of drivers that are already at play in your business, and they're happening. They have happened, they're happening, and they will happen. Past, present, future. Managed remote operations. Your systems are getting more complex. The number of PLCs is going up. The amount of logic in each is going up. The number of sensors are going up. Systems are getting more interconnected. You're starting to see things like off-net license servers and databases and historians in the cloud and big data and predictive maintenance. And the system you want to buy, the vendor needs access. They won't sell it to you if they don't have access. John Deere did that with tractors. And efficiency is more of a driver. Look, your budget's not going up as fast as your needs, and there's inflation and yada, 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 and predictive analytics, and mean time to repair, and inventory management and stuff. This is all happening, and it's all happening with a set of technologies that are worldwide interconnected, not isolated inside your little island. The SaaSification. Look, it used to be you bought something as capital, you ran it for 25 years, and then you scrapped it. And now, look, we went from CDs. When I was in university, we'd go to the store and browse racks of CDs and choose where you'd spend your $20. And I don't know where you get a CD now because it's music as a service. John Deere made tractors as a service. You are starting to see things that you are buying that will not be, not bought, but are rented. The manufacturers want to and need to make more money. They need to have an ongoing revenue flow. They're no longer satisfied with just selling as capital. It's not going to be available. So in the limit, everything in your plan is going to be rented in OpEx, and you're going to be kicking and screaming or embracing it, but it's not a decision you're going to be in control of. Big data. Look, big data was one of the last big things, somewhere between blockchain and AI. Big data was the buzzword of the day. Big data is still a thing. It didn't go away. All these databases and Splunk and Snowflake and BigQuery and stuff, and big chunks of data. Industrial plants create a lot of data. And it doesn't matter whether they're doing energy production or they're doing water treatment or they're doing manufacturing. There's a lot of things that are measured, and there's a lot of things that are controlled, and there's a lot of things that they're trying to optimize for. And it's moved from being a monthly compliance report where you printed it out and put it on somebody's desk and it got dusty to it's a millisecond value driver, and you've got something in real time using it. And that means you're interconnected. You're not bringing big data to the edge. You're taking your data to the cloud. Look, I know some of you will be investing in edge compute, but I'm telling you right now, you're not going to in the long run. It's too expensive for you to run or too much skill set. You don't have the scale to do it, and you're going to outsource it back again. You may whipsaw back and forth between those two when you look at the cost of renting it, and you're like, oh my God, let's go buy some servers. And then a few years later, when those servers are all stale and one of them has caught fire and stuff, then you'll be like, why did we do this? Nobody knows how this is set up. Zero trust. And so why does this reduce that AI risk? Well, with those shared accounts gone, you don't have to worry about their HR risk. That one vector, if somebody's left that company and the password was well known. Overbroad access is gone. You don't have to worry about somebody got into A and now they can get to B because the permission was only to the thing the user was allowed to. And that lateral traversal means that even if they do breach their way in, they still don't get as much stuff. You get more time to see what's going on. You have an audit trail. That audit trail helps you spot them. Enforcing multi-factor. Look, we all know that your remote access to your HMI doesn't have multi-factor today, and the same for your SSH to that router or PBX. We'll fix that together. Agillicus will make that easy for you to do. And once you have that multi-factor on, it's not like it's bulletproof, but it's pretty close. The AI isn't going to magically crack through your BLE-based, passkey-based multi-factor, and they're going to have physical access to your device. It's a totally different risk of finding your password online versus finding your phone that you left on a bus, right? Those are totally uncorrelated risks. And that's why multi-factor works. It joins two things together that tend not to have conjoined risks. If you remove that VPN entirely, then it means that things just don't have access to everything. And we don't have any shared software to install. You don't have to worry about, it's really a lot simpler. So we go back to the AI. So let's talk about that CISA RVA again. So if you walk down the process that I outlined for you in the webinar today. So the first thing is we talked about AI and agentic world and its magnification for lazy and dumb people. It magnifies their stuff. But I still think they're going to go the same way. It's not going to change their strategy. It's going to change their execution. So their strategy was 42% on valid accounts, 26% on spear phishing, and 10% on brute force. This was the strategies that succeeded. So all of those are materially improved by putting in single sign-on and zero trust. On the first, these are now a singular account, one account per person, with proper first and second factor. There's all kinds of valid user heuristics your identity provider does that you may not be aware of. But if the user tries to sign in twice and two times in the same time in different countries, GUIP blocking, trying to guess a password 3 times in a row and it locks them out. It's in one spot rather than 100 at the edge. When you got 100 things at the edge, I can go password 1, password 1, password 1 across all 100, then 2, password 2. The brute force, you never detect it. But when there's only a single identity provider that it goes through, you're going to detect it. And the person that leaves one of your partner companies is taken out of that system, it stops working right away. That vector is going to become nearly impossible for your attacker to come in. The second is the spear phishing link. So spear phishing link, again, really what I'm doing here is I'm usually sending you an email, but I'm trying to trick you into doing something that coughs up your credentials. It's called actor in the middle. So I craft a web page that looks kind of like yours. And I send you an email saying, hey, I'm your IT team, brand new HR system, log in to see your pay stub. And you do. And you log into what's my system, but you think it's not. And I take those credentials and I apply them to the real system underneath it so you don't see that something's gone wrong. It's kind of like a skimmer, the skimmer that they talk about at your ATM. And you type in your PIN number, 1234, enter, and they get it, but you still get your money. So you don't think that your PIN number's been stolen. Later that day, you get a lot of money stolen, but those spear phishing links, they don't work when you have multi-factor via physical device like a passkey. And it means even if you are tricked into providing something, it just doesn't work. But also, when you make things single sign-on, it's always the same HTML. It looks and feels the same. Your users become part of the solution rather than part of the problem. If they're always seeing the same login experience for every system, they'll spot when the green icon's missing or it's not encrypted or it's a different domain. When you say to them, look, I got 100 systems, there's 100 different ways to log in, good luck telling them to remember when one of those changed. But when there's only one, and on the brute force, well, there's no passwords. You don't have passwords to anything, what are they going to brute force? They got to go back and do the OpenID Connect login flow through these identity providers. It's just not going to happen. So my conclusion, look, AI is here. You can't fight City Hall. It's not going to go away. AI is not a chat interface that people are typing stuff in AI is much more than that. And it's these agentic interfaces. It's reducing the pattern space. It's just making it easier and cheaper for the attacker to do the same thing that they're successfully doing, but to more sites. And that is going to completely lower the bar of where they're going to go to. So it used to be they would go after the 10 most interesting targets. Now they're going to go after the 10,000 most interesting targets. And you are now suddenly in the sweet spot of that, where before you might have been on the periphery of it. I don't know, maybe you're the most interesting target, I'm not sure. But my call to action is, look, that's happened, it's happening, it's going to happen, it's all of those together. Critical infrastructure has multiple user types. Look, the vendor, the integrator, etc. You can't get rid of that, it's part of the business. Critical infrastructure has multiple unpatched systems. Yes, I know that you have unpatched systems in your network, and I know that you did it on purpose because you feel that downtime was a bad thing. And I know that me scolding you isn't going to change that. So you're going to keep having those things, which means that you are low-hanging fruit for some of the attacks that we've talked about today. Critical infrastructure is a target. It used to be you weren't an interesting target because you didn't have any money, and now you're a really interesting target because you're a really good way to embarrass somebody. But also my manufacturing example of Clorox, industrial espionage. There's money, there's embarrassment, there's all kinds of rationale. So suddenly you're becoming more interesting. People start talking smack of each other on the geopolitical stage, and critical infrastructure should be the one that's worried about what's going to happen next. There's going to be a dam that somebody opens the sluice gate at the wrong time. There's going to be a water treatment plant that has too much or too little of some chemical. There's going to be a wastewater plant that goes in a bypass right before you're holding the Olympics. Like Paris worked for years to get the Seine so that they could swim in it. Can you imagine if some attacker had just put all the treatment plants into bypass a week before the Olympics? It would have been merde. Very, very embarrassing. AI is increasing the power, reach, and effectiveness of the attackers. And as a democratizing thing, it's put it well within the reach economically. We're not talking about nation states with rooms full of proprietary algorithms. We're talking about open source models that are running on Open Router. Zero Trust is one of the tools in your defense in depth toolkit. There is no singular tool that fixes the world for you. Sorry about that. I know you wanted the quick fix, the panacea, the silver bullet, but we're not hunting werewolves. Defense in depth is a toolkit for identity and credentials, which is 80% of the valid, successful attacks. It is reducing the impact, reducing the likelihood, increasing the chance you're going to see it. If you make everything be unified authentication for each of those user types, the vendor, the integrator, you, the remote operations, the cloud system, the big data, the this, the that, if all of them have this proper single sign-on, OpenID Connect, multi-factor, that 80% becomes much harder to wiggle through. And back to my bear joke, still funny after all these years, they are going to move down the road and find somebody else because they are lazy. And most important, go to my website, www.agillicus.com, or email us, info@agillicus.com, or we're going to reach out to you after this because we can help. We can make this simple to deploy without any changes. You can be incremental. You could be going today. During the time we did this webinar, you could have had us deployed, and you could have had system 1 and users 1 to 5, and then system 2 with users 1 to 50. You could have been boom, 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 and there's no network changes, etc., etc., etc. We'll make it easy for you. Thank you very much. Appreciate your time today, and bye-bye. Again, email us, info@agillicus.com, or check out our website. Cheers.